Alright, let's take a look at what happens if we're going to basically solve an inequality that's actually a quadratic, and which is going to create like regions that we need to kind of take a look at what's going on. So as we first look at this guy, what we need everyone to realize is that this is not, even though it's an inequality, it's not in standard form. So remember, standard form is kind of key, because if we're in standard form, which is ax squared plus bx plus c is equal to 0, then that's kind of like the magic spot where we can either factor it, we can use the quadratic formula, we can use other methods. But like right now, we're not there because we're not equal to or less than 0. So we need to go ahead and get there. So we're going to subtract 12, subtract 12. At that point, that gives us 7x squared plus 25x minus 12 is less than 0. So now we're there. We're in standard form and we're ready to factor. So we come off the side of our paper and we say product sum factor. And even though we're gonna keep track of that inequality sign here, but you might hear me talk about this as an equal sign. All right. So we take the product. Go ahead and load my calculator. We're gonna need that probably. We take the product of 7 and negative 12. So 7 times negative 12. That's negative 84. Our sum is 25. So remember, we're looking for the factors of 84 that will give us 25. Hit pause while that's loading. There it comes. Never mind. So remember, to do that, we hit y equals. We type in negative 84 divided by x. We go to our second graph, because it's tabled right there in blue. We're looking for two numbers from this list to add together to give us 25. So there we go, 3 and 28. So if we add those together, 3 and 28, we get 31. But if one of them is positive and one of them is negative, now we get 25. We come over here, those are our factors, so we say x minus 3, x plus 28. I'm going to say equals 0. Don't panic about that, okay? It's okay, it'll come back. Remember, we have a leading coefficient, so we need to put that leading coefficient underneath. So we put that 7 underneath right there, and we put that 7 underneath right there. And now we say to ourselves, does 7 go into 3? The answer is no, so we move that 7 out in front. This becomes 7x minus 3. Does 7 go into 28? The answer is yes, so we get x plus 4 equals 0. Remember, those are our factors. In this case here, we need to go all the way to our solutions, because we need to know the numbers that actually will make us equal 0 or be there at that spot. So we take each one of these. We take the 7x minus 3, we set it equal to 0. We take the x plus 4, we set it equal to 0, and we get x equals negative 4. We get 7x equals 3 and x equals 3 over 7. So these are what I call, which is not a mathematical term, but I call those my landmarks. Those are kind of like my boundaries. That's not how you spell boundaries, is it? Those are my boundaries. Those are the numbers that create a separation when we actually start thinking about this. Let's come back up to that. Now, our next thing is that we need to make a number line. And this number line, this is one of the most important parts of this problem. So we've got 0, that's our landmark. We got negative 4, so 1, 2, 3, 4. And I'll just go a couple more, 5, 6. Remember, this would be negative infinity out here. We go this way, that would be 1, 2, 3, 4, 5. I'll just put a 5 right there. So we have negative 4. And so negative 4 is a landmark, a boundary. And so I actually draw like a dotted line to kind of create that boundary. And you'll see why in just a minute, a wall of sorts. And then we have 3/7. Well, I hope everyone knows that the 3/7 is between 0 and 1. If you're not 100% sure, you can always take your calculator and go to your home screen, and you can take 3 and divide it by 7, and it'll tell you that it's 0.42. Hit the wrong button. So that means that this landmark, the 3/7, is going to come maybe like right here or something, approximately. So now we draw a wall that passes through that spot. and that's my 3/7. So what I want you to understand is that we've created these boundaries because we have regions, and we have to think about these regions and establish where the solutions might come that would make this original problem true. I mean, that's our goal, is that we want to figure out what x's can I plug into this guy right here. What can I plug in right there that will make this true, will make this side less than 0? So we come over here, and what we do is we establish some test values. So I need a number from this region. It doesn't matter what number it is. It's not going to be -4. So let's test -5 or -6 or -7 or -8, whatever you like. I'm just going to test -5. That way my numbers don't get too big. Let's choose a number that we can test in between the two boundaries here. So we need a number between -4 and 3/7. So the easiest number is x equals 0, because that's right there. It's inside the boundary. It's easy to plug in. You could choose -1. You could choose -2. You could choose -3. We come over to the third region, and we need to choose a value. And over here, so this is 1, this is 2, this is 3, this is 4. I could choose 1. I'm just going to choose 2 just for the sake of conversation. So remember, there's my 2 right there. I'm going to change my colors on this one, and we'll go to red on this one. So remember, we said we're going to test x equals 0 on this side, and then over here we're going to test x equals -5. So we'll start off with a -5. We're going to test that and see if it makes my inequality true. So you could take your original equation, or we can just take this guy. Either one will be okay. So I'm going to use the original just for the sake of conversation. So we've got 7 times -5 squared plus 25 times -5. And the question is that side, is the left-hand side less than 12? So we pull out our calculator, put it on top real quick, and we plug it in. So we got 7, open parentheses, -5, close parentheses, squared, plus 25, open parentheses, -5. Close it, enter. So that means that 50 is less than 12, and that is a false statement. That means that this region right here is false. That means any number that I choose from this region right here will not make this inequality true. We go to the second region. So in the second region, we have 7 times 0 squared plus 25 times 0. And the question is, will that be less than 12? Well, 0 squared is 0. 0 times anything is 0. Plus 0 times anything is 0. So 0 is less than 12, and that is a true statement. That means that any numbers that we choose from this 3.7 or 3/7 to -4 will make this inequality true. We go to the last region, we test our 2. So we do 7 times 2 squared plus 25 times 2, and the question is that less than 12? Pull out our calculator for this one. So we've got 7, open parentheses, 2 squared plus 25, open parentheses, 2. So it says that 78 is less than 12. We know that's a false statement, so therefore any numbers that I choose from this region, whether it be 1, 2, 3, 4, 5, so forth, all the way to infinity, will make this statement false. So that's establishing our regions, so we can test our regions. Once we have our regions established, then at that point we can actually get to our final solution. So our final solution is, and let's go back and remind ourselves, remember that our inequality was a less than symbol. So since our inequality is a less than symbol, our solution is from -4 to 3/7 is where we'll find our solutions, and it'll be in open parentheses because of the less than. And we're between, right? We're between these two, and that's what this interval notation says. Remember, this is interval notation. All right, so play around with that. Send me questions. I'm not going to over video this one. I'm going to leave it at that, and good luck.